M1 is how much? 10. M2 is 5. M3 is mixture. Correct? To do it. Sorry, M3 is total, yes. So correct. This is simple calculation. Calculator. Done. This to be just calculator part. इसके लिए बाकी कोई जरूरत नहीं. So you get 0.55 as the mixture. So now you have to draw a line corresponding to 0.55 vertical as shown over here, and wherever it cuts the line joining 1 and 2, that is your 0.3. Correct? This is what we have seen. Huh? 5 plus 10 is 15. Yes, no, M1 plus M2. 5 plus 10. M1 is 10, M2 is 5, M3 is total. Done. So you find the intersection over here, vertical line from 0.55, and wherever it cuts the line joining 1 and 2, that is your 0.3. Find it on the chart. आपने क्या किया? 5 लोगों में एक चार्ट और वो 5 का एक. पण ते तुम्हाला वाचायला फार अवघड पडणार. क्लास टेबल लोक कोण कसं आलं? मी ऑफर पासून येतो. पुरा 17-19 लोकांना याचं मी कसं कॉपी करायचं म्हणून ना परीक्षेमध्ये मी ऑफलाईनचा पेपर नुसतं का ऑनलाईनचा नुसतं नक्की करून स्क्रीन दिसलं सर सगळं किंवा असं करू थिअरी आपण ऑफलाईनला विचारतो आणि सम सांगतो. आम्ही फक्त मेहनत घेतो. तुम्ही जसं काही जीवावर उदाहरण घेता तुम्ही मेहनत घेता. Online people, you got the intersection? 0.553 vertical and the line joining 1 and 2, wherever it cuts. That is intersection, that is your 0.3. Are you getting it?
No, sir, doing it, sir.
Why so much time? It's just 5 से vertical line लेना है बाबा. And 1 and 2 को तो already locate कर चुके. Draw one line and find it. If you will be wasting the time, you will be at slack finally. Huge portion is remaining. Then I have to give it a self-study. Time given by college is very limited, restricted. Here the offline people have got it. So how much time to waste for online people? That is a disputable matter. आपका हो गया offline. Now what you have to see is 6.9 bar. Your state 1 and state 2 both are 6.9 given. So mixture is 6.9. Now you try to locate 6.9 bar ka line and find out 0.3, whether it is above 6.9 or below 6.9 or on 6.9 bar. What? 0.3. So 0.3 falls above 6.9 bar line. Do you agree? That means it is in two phase. Line पे होता saturated, नीचे होता subcool. Above means two phase. So now we are asked question number 1, mixture concentration. You got it, 0.55. Correct. Second part, mixture enthalpy. You can read it. Not a big problem. Y-axis. The third part, equilibrium temperature of the mixture. How you will find it? Because your mixture now is in the two phase zone. And in two phase we do not have the isotherms. Equilibrium construction. One vertical, one horizontal. So which line, as you can see in the, here, this way. Blue color line. That is the isotherm. I don't know. It is somewhere above. So which point actually should be there, that I don't know. So now you observe, I will explain with the help of the chart only. Let's say this is your point 3. Now by trial and error, you have to fix point F somewhere over here. 6.9 ki line na? Cannot change the pressure. So 6.9 ki line pe you have to, let's say, randomly take one point. Okay, that is F. Assume. Then go vertically upward. That is your equilibrium construction line. Then read over here, equilibrium condensation line. Okay, and then whatever point you get over here as G, then point F assumed, point 3 which you got, and point F which you calculated must fall on the same line. Then and then only it is the isotherm. Assume point F on 6.9 bar. Construct one vertical, one horizontal, equilibrium construction line. You will get some point G. Look at the chart. G. Then your F, 3 and G should fall on the same line. F and G may fall on the same line. 3 must be there. So that is by trial and error. So do it now. Assume. And once you find that particular line, F3G, then you read that temperature. Online people, any difficulty? I have repeated also one more time. If you want still, I will repeat third time, no problem. Are you clear?
Yes, sir. Yes, sir.
So assume any F point on 6.9 bar, equilibrium construction line, right angle triangle, find out G and cross check F3G must fall on the same line. No difference in the slopes as shown in the figure. And if you get that particular isotherm F3G, then read F temperature. That is your what you can say, mixture temperature. So F is the saturated liquid, G is the saturated vapor, 3 is the two phase part. F3G simultaneously right angle triangle. Conditions simultaneously. One is actually one is not one is right and one is right angle. Both are right. That is the constraint. Or other, those are the constraints. You can always make a hypotenuse, but we not be right angle. ऐसा कोई भी लाइन बना दो, तो right angle हो रहा है नहीं, because here 6.9, here 6.9, here 6.9. What happens? है ना पहला शॉट है ना? इलेवन डिग्री कुछ भी उसको तो satisfied है Star Wars. Hello, online people, are you getting it? Any difficulty? Anyone got the answer?
Yes, sir.
Cross check the temperature. I have given you answer 43.33 degrees Celsius. You can see it over here.
Yes, sir. It is matching.
So you have to satisfy two simultaneous conditions. One is that if let's call this point, इसको क्या बोलेंगे? Equilibrium construction line है ना, C बोलते हैं, चलो. So F3G on a straight line and FCG as a right angle triangle, both have to get satisfied for the same pressure of 690 kPa. आपका हो गया? सेकंड बैच करो करो. आंसर में पड़ा है तो इंजीनियर हो, आंसर माइनस करने का सही काट दो. Somewhat here and there. And एकतर ते काय त्याचं लिस्ट काउंट आणि सगळाच आनंद आहे. Okay, so you got the isotherm. The offline people got around 40. My answer is 43.33 because I use the computerized resolution. So that is more accurate. What about online people? S3 check करा. 80. Fine. So we did the same thing. Trial and error. F3G as our isotherm. Then we read the temperature corresponding to F. And whatever you got, 40, 41, 42, 43, 45, whatever it is. Fine. Now the last part asked is about the percentage, correct, of the liquid and vapor. So total length F2G is known. Find out the percentage. It is just above 690 saturated. That means the small part is the vapor. Big part is liquid. F23 divided by total. That is your vapor part. And 32G divided by Fg. That is the liquid part. Correct? Cross check. Measure your length. Online people, are you getting the answer? Any doubt? 0.9 matlab? 95%. Okay. 90% है तो गलत. 95, 96, 97, 98. That is okay. Done. Online people. Should I move ahead? Offline people have completed. Are you getting the answer or not? What is the problem?
Yes, sir. Getting around 40 degrees.
40 degrees. Okay. And the length, fraction? 40 degrees is okay. Fraction length, either you measure in terms of 3G by Fg or F3 by Fg. If you refer to 3G part, it would be vapor. Sorry, liquid. And F3 would be the vapor part. Your 0.3 is just above the saturation. So small amount is vapor, large amount is still liquid. Your 0.3 is traveling from F liquid to G vapor. So close to F means very small amount of vapor. उल्टा होता है ना liver rule.
Yes, sir.
If your 0.3 is close to G, that means majority is converted into vapor. Very small amount remaining is liquid. So are you getting the fraction?
Sir, around 4%.
4%. Fine, no problem. 4, 5, 6. That's not an issue. Okay. Now the next process. Here we involve the heat transfer. अभी तक adiabatic. So what will be the change? Would be only 1, 2, mixing and heat transfer. It may be plus Q minus Q. So it depends as per the condition whatever I will give in the numerical. Either heat absorption or heat rejection. Depends. Okay. Baki sab same. So at such, state 1, okay, let's say liquid. State 2, somewhere in vapor. Plus state 3, somewhere in between, two phase. Then I may ask the question in a way, let's say this is your state 3. That how much heat is to be rejected to bring back the solution to the liquid line? Or how much heat is to be added to bring the solution to the vapor line? Done. आपका two phase है, for example. So I will ask you how much heat is to be rejected so that it would be saturated liquid, or how much heat is to be added to bring it to saturated vapor. So either it would be plus Q or minus Q. So if we apply the same logic M1H1 plus M2H3, M2H2 is equal to M3H3 plus or minus Q. For the sake of writing, I have written plus Q. That's not compulsory. Plus or minus Q. Mass balance may no problem. M1 plus M2, M3. And why concentration would change? It's only the heat transfer. Heat transfer is vertical because your y-axis is enthalpy. Heat transfer is basically enthalpy transfer. So that is vertical. Concentration change not take place. Doesn't take place. Correct? That is not applicable. So whether it is 3 as a two phase or 3 as a saturated liquid or 3 as a saturated vapor, concentration is same, vertical. So M1X1 plus M2X2 equal to M3X3 remains same. There is no question of any Q. This Q is getting added only in the first part. Energy balance. Mass balance independent, concentration balance independent. Only in energy balance. Correct? So as far as X3 to be found out, logic same, formula same. Only there is change in X3 where you have to consider either plus Q or minus Q, whatever as per asked. Correct? First two terms same, H1 plus M2 by M3 into delta H, H2 minus H1. That is as same. If I put Q is equal to 0, that is your adiabatic mixing. Same. So since here I have put plus Q, here it is minus Q. Again, I am repeating, that is not compulsory. It solely depends on the way I ask you the question. If I ask you to calculate the heat to be removed, accordingly. If I ask you to calculate the heat added for achieving the vapor state, accordingly, plus Q or minus Q. Okay, logically very, very simple. Fine. Online people, any doubt? Online people, any doubt? Should I move ahead?
Yes, sir. Yes, sir.
Solve the example. 1 kg per minute of saturated ammonia vapor. Very loud given. Okay, x equal to 1. End. X-axis end. Extreme right. X equal to 1 diya hua hai. Correct. What is the pressure given? 2.07 bar. 207 kPa. Locate. 207 kPa and x equal to 1. Okay. Is mixed with 10 kg per minute of saturated liquid aqua ammonia. Very loudly given. No subcooling, no two phase, nothing. Saturated liquid. For that, what is further given to me? 2.07 bar. Pressure is same. And 37.8 degrees Celsius. You can find out that isotherm. Correct? So 37.8 degrees temperature line and 207 kPa pressure line intersection. Liquid part. Okay? That is my point 2. Point 1 is direct vapor. X equal to 1. 207 kPa. Locate the 2 points. What is asked? Find the mixture state. Final mixture state is a saturated liquid. Very loudly. एक है saturated liquid, एक है saturated vapor. That means mixture will be two phase. And I am given that final mixture state is the saturated liquid. That means you have to reject it. Correct? So how much? We will calculate. हो म्हणून तर पेन्सिलने करा म्हणजे ते तुम्हाला रब करता येईल. Mixture hello try करो. I should concentrate. हाँ उधर मुझे करना पड़ेगा. रखते हो क्योंकि आपको क्या चाहिए इसे मिलता भी नहीं. कोण आलं त्यांनी ते केलं ते करून दिसत नाही इतर कोणाला दिसत नाही. Online people, what is concentration x2? X1 very loudly given.
Sir, 0.34.
हाँ ठीक है 34 33 35 whatever it is. Okay. Right, my value is 0.4. How come you are at so less? No, sorry, 0.34, correct. So you can find out mixture enthalpy. 0.345 I got as your 0.1 or 0.2, whatever you call that, as the concentration value. Second is given loudly, that is 1. So mixture enthalpy, not enthalpy, concentration. Mixture concentration, correct?
1 plus 1 minus 1.
Ah,
1 point right. 1 point right.
नाही मी 1 इकडे घेतला माझा 1 लेफ्ट आहे आणि 2 तिकडचा नाही x2 is 1 ये क्या x2 is 1 x1 is this. The way you write accordingly substitute. आपने 2 लिया रेफरेंस तो माइनस करना पड़ेगा 1 लिया तो प्लस करना पड़ेगा. Fine. So now this is my point 3 dash and you can locate it now 0.405 vertical line wherever it cuts 1 and 2 joining. तो हो गया. Now the question asked is to calculate the heat exchange. Now we know that it has to be rejected to bring that 3 dash back to 3. Where is 3? Saturated liquid line. So you know saturated liquid point. उसका एंथैल्पी रीड करो. टू फेज का एंथैल्पी रीड करो. मास इज नोन kJ per kg multiplied by total kg will be the total kg. करेक्ट. स्टेट 3 डैश हो गया. क्रॉस चेक योर H3. Is your H3 correct? Three and 3 dash, both enthalpy values. काय झालं टेम्परेचर आलं का 3 dash आपोआपच आलं ना. 1 and 2 join and the vertical line 405 0.405. 3 पॉइंट जो आपको मिला उसका टेम्परेचर माय वैल्यू इज 26.6 आइए 1 नहीं 1 is constant pressure 207 देखिए कितने का मालूम नहीं है minus 65 मतलब तुमचा टेम्परेचर वाइज या पैरेलल होता है याचा बेसिक जो लिस्ट काउंट सिंगल प्लस 40 बरोबर आहे त्याच्यामध्ये अप्रॉक्सिमेशन करून करून किती करणार दॅट इज युअर स्किल आय एम नॉट व्हेरी स्पेसिफिक अबाउट दॅट So are you getting the online people? Are you getting the values of the temperature and enthalpy shown? May not be exact, but close. Offline people got it over here.
Why don't we take the same pressure like and
म्हणजे
pressure line pressure line
आपल्याला त्यांनी सांगितलं काय आहे की फायनल स्टेट इज द सॅच्युरेटेड लिक्विड ऑफ द सेम प्रेशर ना वाय टेम्परेचर मेंटेन केलं तर मग लिक्विडला येईलच कसं हॅज टू रिजेक्ट द हीट हा ऑनलाइन पीपल आर यू गेटिंग T3 H3 somewhat similar?
Yes, sir.
Good. How much temperature? How much enthalpy? अरे कौन है ये सर वाला बोलो ना
हाँ सर, एक मिनट है.
-45 आ रहा है सर एंथल
-45 ठीक है 30 people
45.
got here -65 that is okay your least count is 40 so making the fraction in that may be a difficult task I agree I'm not very specific about the exact value temperature -45 तो enthalpy होगा what is temperature
So near about 28.
you have to read the temperature at 3 not 1 1 and 3 are on the same pressure not temperature temperatures are different because you have rejected the heat correct so temperatures are different they are bound to be different okay now total Q you want to calculate correct so Q is equal to total mass into enthalpy difference so H3 and H3 dash hey read 3 value no sorry 3 dash my value is 125.6 3 dash you have not found out no you found only H3 that is -65 or whatever your value whatever is so that is the delta H multiplied by total mass that is the total heat correct done any problem offline people the other batch any problem H3 dash correct fine online people any problem H3 you have read whatever -45 H3 dash that also you can read y-axis enthalpy axis that is the difference 3 dash to 3 is the cooling to bring it back to the liquid state saturated liquid state and corresponding temperature is 26.6, whatever I got, your value, whatever, 24, 28, whatever. Fine, any doubt? Should I move ahead?
Yes, sir.
What? Doubt, yes sir, or move ahead, yes sir?
Sir, you can move ahead.
Now the third process, how much time left? The third process is simple condensation and evaporation, which is just the what I can say extension of whatever we have just done. Okay. So here you can say liquid 1 coming in. There is no example with this method. So I can finish this. Liquid coming in. You add the heat. Okay. So it will be somewhere in two phase. Then you take down the liquid as 3. Over here we call this as separator A. You take down the liquid 3. Vapor 4 goes over here. Then the next heat exchanger where you reject the heat. Okay. Because of that, your 5 will be again in two phase. Then again you can take down the liquid at 6, remaining vapor at 7. So whenever you use the binary mixture, this typical technique is used to separate the two components. Component A liquid, 3, 6, go on. Component B vapor, 4, 7, and go on. Okay, this liquid 1 is a binary mixture, let's say. Fine, component A, component B. I know about boiling point of component A. So I will add the heat in such a way that component A will be in two phase. And I will take down the liquid part. Vapor, component B as it is. And a little bit of A also, maybe, possible. ऐसा थोड़ी है कि पूरा का पूरा निकल गया. So B is in vapor, 100%. And A may be in vapor. Then I will reject the heat. So again A, liquid. A is still in vapor. B boiling point will be too high, for example. It is still in vapor. Hey, not too high, too low. But it is still in vapor. And A will be, whenever heat rejected, liquid.
At point 2, B is total vapor and A is in between, like vapor and liquid.
What is A?
Means A is
Component A.
yeah, component. It is in liquid and
Vapor phase.
At point
Same जो अभी किया था example, same 1 and 3 के बीच, 1 and 2 के बीच. So I add some heat in the heat exchanger A, Q1 to 2, so that component A will be between liquid and vapor, 1 and 2. Component B is in vapor only. उसको रहने दो. So B we have nothing to do with. A we are focusing on. And how we are separating? Add the heat, bring it in two phase, remove the heat, condensation. Again add the heat in the remaining vapor form. Bring it in two phase, remove the heat, take out the condensation. So this condensation evaporation continuously in series if I go on adding. Now here only two heat exchangers,
But Q4
1
should always be
and
less than
2.
Q1.
Huh?
Q4 should always be less than Q1.
Why so?
So because if it's more then B could also start like what you say condensing.
No, that's only depends on the boiling points. More or less I can't say. That depends on the boiling points. The difference in the boiling points of component A and B. That
But
you have to
Q4
focus
should
on.
actually always be less than Q1, you know.
Not mandatory. Why?
So because if it's more than what if it reaches B?
You will get more and more liquid, no?
So what if it reaches B boiling point?
मैं तो वही तो बोल रहा हूँ ना, B का boiling point पे ही आपको decide करना है. More or less you cannot say. That's only depends on the boiling points, magnitude. Don't quantify, don't qualify the things, quantify. Okay, so if you go on adding like such heat exchangers in series, then that is something called as the rectification process. because you are separating the two components. One or no, not one. A in liquid form and B in vapor form. Okay, so that is called as the rectification process. Basic logic or thermodynamic process is condensation and vaporization. At one time you are adding the heat, bring it into phase, reduce the heat, take out the liquid. So minimum two heat exchangers required. I call this as one state, one stage, then second stage, third stage, fourth stage. That number of stages depends on the quality of the purity. If you want 99% pure liquid, maybe 10 stages. If you want 99.99% purity, maybe 20 stages. Because you are separating the two components. So how much pure you want the concentration? Concentration can be some X value, but how much pure that concentration is? Okay. So only the concentration is not important, the purity. Concentration, okay, say for example 0.5 million, fine. Is it pure? 100% pure? We don't know. Let's take a simple example of the atmospheric air. Concentration of oxygen, nitrogen, fixed. Is it pure? If I want pure oxygen, then I have like whatever 99.99% pure oxygen. Then I have to go on rigorous processes to eliminate all other gases. It's not going to happen in one single step, no. Nitrogen and oxygen, उसमें कुछ argon आया, krypton आया, helium आया. So the number of stages which go on adding adds to the purity, concentration. Are you getting it, online people? Yes or no?
Yes, sir.
Okay. So we will continue with this thing in the next lecture. Why I introduced it over here, because this is the extension of the earlier process. So the mass balance, energy balance, वगैरह वगैरह ये सब next lecture, tomorrow. उधर से ना? Tomorrow. Okay. Any doubt to anyone up to this part? Online people, offline तो मेरे सामने.
No, sir.
Okay, good. So should I end the meet?